Hello viewers, in today's class we are going to discuss one important concept in three-dimensional geometry, right? So here we'll find the equation of a plane which passes through some given point and parallel to two given lines, right? So here we'll discuss this concept with the help of this example, right? So let us start and let us first read out the problem. Find the equation of the plane passing through 4 comma minus 1 comma 2 and parallel to these two lines, right? So here we are given the first line as L1 and the second line as L2, right? So here let us first draw a rough diagram. Suppose this is the required plane, right? And let us draw this plane like this, and let us denote this plane by the letter pi, right? And this plane pi, it passes through some point. Let us say this point as A, right? So this is 4 comma minus 1 comma 2, right? And moreover we are given that this plane is parallel to these two lines, right? So let us draw the first line like this. This is the line L1, and let us draw the second line as L2, right? Suppose this is the second line L2, right? So this plane pi is parallel to L1, and pi is also parallel to L2, right? Okay, so now we have to find the equation of the plane pi, right? So we know that any equation of this form, say ax plus by plus cz plus d is equal to 0, it always represents a plane, right? Now if we know a point on the plane, then we can modify this equation as a times x minus x1 plus b times y minus y1 plus c times z minus z1 is equal to 0, right? So here in this case we have the four constants, right? A, B, C and D, right? So we have four unknown parameters here, but in this equation we have only three parameters, that is A, B and C, right? So once we know the coordinates of any point lying on the plane, then we can modify this equation, and we can modify it to this one, right? So let us now assume that the equation of this plane pi is given by this equation, where x1 y1 z1 are the points 4 comma minus 1 comma 2, right? So now let us substitute the values of x1, y1, z1 as 4, minus 1 and 2 in this equation number 1, right? So we'll have a times x minus 4, then we have b times y plus 1, and c times z minus 2 is equal to 0, right? Now here we must remember one thing, right? These A, B, C, the coefficients of x, y and z are the direction ratios of the normal vector to this plane pi, right? So A, B, C are the direction ratios of the normal vector, right? So let us draw the normal vector like this. Suppose this is the normal vector, right? And see, this vector is vector n. So this plane pi is parallel to this line L1. So this normal vector must be perpendicular to this line L1, right? So this angle is pi by 2, that is 90 degrees. Similarly, this plane pi is parallel to this line L2, right? So this normal vector is also perpendicular to this line L2, right? So this is 90 degrees, right? So we see that the normal vector is perpendicular to L1, and the normal vector is also perpendicular to the line L2, right? Now let us denote this equation by equation number 2, right? See here we have A, B and C, and A, B, C are the direction ratios of the normal vector. So once we know the values of A, B, C, we can easily find out the equation of the plane pi, right? Okay, now see here first we'll take the line L1, right? Now see the direction ratios of the line L1 are given by these denominators, that is 3, -1 and 2, right? So the DRs of the line L1 are 3, -1 and 2, and similarly the DRs of the line L2 are given by 1, 2 and 3, right? So here we have 1, 2 and 3. Okay, now see the normal vector is perpendicular to L1, right? And the DRs of the normal vector are A, B and C, right? And this normal vector is also perpendicular to L2. So we have here again the direction ratios of vector n as ABC, right? Now see, when this normal vector is perpendicular to L1, then we have the equation that is if two vectors are perpendicular, then we have the condition that is a1 a2 plus b1 b2 plus c1 c2 is equal to 0, right? So if two vectors having the direction ratios a1 b1 c1 and a2 b2 c2, then their dot product must be equal to 0, right? So the dot product must be equal to 0. So we have a1 a2 plus b1 b2 plus c1 c2 is equal to 0. So here we'll take the dot product of these two vectors, and similarly the dot product of these two vectors. So utilizing this condition, we have 3a, then we have -1 times b is minus b, then we have 2 times c, right? And this is equal to 0. And similarly here we have 1 times a is a, then 2 times b is 2b, and then 3 times c is 3c, right? So now we have two equations in three variables, that is a, b and c, right? So now here we have to solve these two equations, right? And here we see that the number of unknown variables are 3, that is a, b, c, and the number of equations are less than the number of variables, right? Because we have only two equations to solve and to find the values of three unknowns, right? So what we usually do here, we first select any one of the variables and try to eliminate that variable, right? So here we'll select the variable b, right? And we'll multiply. See, I'm writing these two equations like this, and here we have a plus 2b plus 3c is equal to 0, right? So let us select the variable b, and let us multiply the first equation by 2. So we'll get 6a, and here we have 2b, then we have 4c, right? And now we'll add these two equations, right? So we'll eliminate any one of the variable. So here these two get cancelled, so we have 7a, here we have 7c is equal to 0. So we can now write a plus c is equal to 0. So a is equal to minus c, right? So what we have done here, we have selected any one of the variable, that is b here, and we eliminated b, and then we get this equation, right? So now we have a is equal to minus c, and let us take a scalar, say k, right? So here k is some scalar or a real number, right? So the value of a is k, and the value of c is minus k, right? Now let us substitute a and c in this equation, right? So what we will get, we'll get k plus 2b, then we have minus 3k is equal to 0. So 2b minus 2k is equal to 0. So 2b is equal to 2k. So b is equal to k, right? So we have b is equal to k, right? So now by introducing this real number k, we have expressed a, b and c in terms of k, right? And now since k is not equal to 0, so we can substitute a, b and c in equation number 2, right? So what we will get, c will get k, then we have x minus 4, then we have b, that is k, y plus 1, and then we have minus k, that is c is equal to minus k, and here we have z minus 2 is equal to 0, right? So now since k is not equal to 0 here, and we can now write this equation as x minus 4, and here we can write y plus 1, and here since we can easily eliminate k by taking k as common, and k is not equal to 0, so here we have minus z plus 2 is equal to 0, right? So we have x plus y minus z, and here we have 2 plus 1 3, 3 minus 4 is minus 1, right? So this is the required Cartesian equation of this plane pi, which contains or which passes through this point 4 comma minus 1 comma 2 and parallel to these two lines, right? Now we can also express this Cartesian equation in the form of vectors, right? So we can now write the equation of this plane pi in vector form as vector r dot vector n is equal to d. So here we can now write vector r, and for vector n we have I cap, then plus j cap minus k cap, and here we have minus 1 is equal to 0, because here the coefficients of x, y and z are 1, 1 and minus 1, right? So the direction ratios of the normal vector can be taken as 1, 1 and minus 1, right? So if we take this 1 to this side, so we have vector r dot I cap plus j cap minus k cap is equal to 1, right? So this is the vector equation of this plane pi.